Hello everybody. Today I will start my first video of the fluid mechanics series, and it's kind of weird, right? You thought like the first video of fluid mechanics series would be definition of pressure, force, like what does flow, how do I define flow, and how do I define like friction and stuff, right? But I start with a differential equation. Honestly, the reason why I did it is because this is very emotional to me. Me and Dr. Let me say his name correctly. Dr. Nikolaus Malamateris has it's mostly him actually. It's mostly there's one differential equation on the fluid mechanics textbook. It's the page, and the things right here. It's kind of I'm kind of intrigued by it, and I asked Dr. Malamateris to solve it. Because if you look at this is differential equation right here. F double prime plus F prime cotangent of theta plus F times 1 minus cotangent of theta squared equals 0 is completely non-linear second order, so you cannot find general solution, right? But Dr. Malamateris actually go and set up like an educated guess, which will reduce this differential equation to something easier, something that we are able to solve. And yeah, it's just mostly his word. So in this video, I'm just gonna convey his message, but there's something I did differently from him. But Dr. Mehmet, this is his email. If you're curious about his courses, I encourage you to reach out to him to learn about his research and stuff. It is just he's I can never forget him. So Dr. Malamateris, if you're watching this video, Poli, thank you so much. And to your audience, I hope that this video, like, it would teach you a little bit like how to reasoning and how to come up with and although like we don't have a general solution for nonlinear second order differential equation yet, but I hope that you get something out of this video. So without being saying further, let's go ahead and jump. So how do we solve this differential equation, right? So what you're gonna do is, if I didn't say anything, is Dr. Malamateris' work, like it's on his derivation, on his work. It just, I feel like it's so emotional that I have to put a video. I have to make a video about it. But when it comes to my part, I'll let y'all know. Like that is when I did differently from him. Okay, I did a little bit different, and then I will also tell like why his way is better than I do. Although I did a little bit different and it make more sense to y'all, but I'll explain later. Okay. So now this is a differential equation, right? The unknown is the function f. We need to find a function f, and f is a function of theta, right? So f is a function of theta. So how are we gonna solve this, right? We gonna solve this by making an ansatz, right? What is ansatz? An ansatz, ANSTZ, is an educated guess. This is an educated guess. So what's our goal right here? Our goal is we have to reduce. Let me name this number 1. We have to reduce equation 1 to something that we are able to solve, right? So what's that thing we are able to solve? And so Dr. Malamateris' proposal for the ansatz is we're gonna reduce equation 1 to g times alpha f plus beta f prime. Okay, so what is g, what's alpha, what's beta? G, alpha, beta is a function. I can say a function. It's a function of theta. Okay, and now I know a lot of people, a lot of y'all, listening and ask like, why Justin, why you reduce that? Why would Dr. Mamateris reduce this form, right? Um, why be another different form? Why is not? I'm gonna attempt to answer your own question by doing a serious Q&A right now. Like I'm debating myself right now. Like, if you see that meme on YouTube, like Dr. Jordan Peterson, like, when he talked to, I forgot a lady's name, but it gets so bored that he literally debate himself. Anyway, that's not the point. The point, okay, I'm gonna come up with some Q&A, okay? Q&A, okay? Why do we pick such answer? Right? Why it have to be some g times alpha f plus beta f prime and then all of that prime, right? Why would it not be otherwise? So the reason why is this: you have to remember the goal, right? The goal is you have to reduce one to something we're able to solve. And so far, what are we able to solve? We are able to solve like first order differential equation. Differential equation. Where is linear or not linear? Okay, where is linear, where is not linear, we can solve it. Okay, and then I'll later I would tell y'all like how do you solve it. Like that's what I learned from EMAT in University of Houston. The course is Math 3321. It's called engineering mathematics. But if you're interested, sign up for that. You're gonna learn a lot. A lot of people's you're gonna learn a lot. Okay, back to the point. We have so the first order differential equation, right? We are able to solve. Again, if you reduce to something like this, beta f prime plus let's say mu times f prime, right? If you reduce something like this, I mean, you can technically reduce to something like this, but you see, the reason why we don't reduce to this is because we don't want to generate something we cannot solve, right? You have to, the golden answer is you have to create something you can solve. This is a second order nonlinear differential equation. We don't have a general solution for this, and you see it's kind of weird because we start up the problem with a second order differential equation, and you want to reduce it to a second order nonlinear differential equation. Okay, sorry, I take it back. Okay, let me say slowly. We start up with a second order nonlinear differential equation, right? We want to change it. We want to change it in some way, but now you're telling me that you want to reduce it to a second order nonlinear differential equation. It's kind of weird, right? This is something you want to escape from, and then you come back to it. What is this? Back to you, Selena Gomez? Oh man, definitely not now, man. Like, no, not now. Yeah, honestly, not now. And you cannot reduce, you cannot put in higher order either. It's obvious. You cannot solve it. So, okay, first order differential equation. Okay, this is the answer. So that's why we do it that way. So, and the second question, like most of y'all might have, is why do we times g, right? Why we have, let me write that again. Why do we have this term g right here, and g is a function of theta? Because we want to generalize. We be as much general as we can. Okay? We want to be as much general as we can because you don't know. You don't know like how can we generate it. It can be a number, it can be, it can be 2, it can be 3, it can be 4, it can, be, sine x, it can be sine theta, it can be theta squared, g can be anything. So we don't want g to be a number, right? We want g to be a function because we want to be as much generalized as we can. So g, we pick g because g is the most generalized thing. There's nothing more generalized than that, apparently. If you pick g square, well, just g. because chi squared is a function, right? It's a function of theta. Here we want a function of theta, so a function of theta we just denote chi. Okay, anything else in the world, anything else is a function of theta. So the goal of it, again, we try to reduce 1 to a function of theta, in this case chi, times alpha f plus beta f prime prime. Okay. Another question I think y'all might have is why don't we reduce this, right? Let me actually y'all have, yeah. Why don't we reduce this? Mu, right? When mu is a function of f. Now, the reason why we don't do this, because if you look at the first equation 1, you see everything here, they have the coefficient of f, right? You see what I'm saying? So if you differentiate this, when you differentiate this, it won't have f or f prime or f prime prime as a coefficient. What I mean is when you phone this term out, when you phone this blue term out right here, mu mu will be redundant because it not there, it should not be there, because you have to have a function of f. You have to have, you look at 1 again, look at 1 closely. You want to construct something similar to 1, right? So you look like they only have f prime prime times something, f prime times something, f times something. If you have mu and then you for it later, I guess like you have a bunch of thing and then you plus chi times mu prime, right? This is a function of theta. This is a function of theta, right? Where's f? You're supposed to have some coefficient f next to it, right? Where are you? Where are you now, Atlantic? Under the sea, Alan Walker would be disappointed. Anyway, it means that you cannot have a mu here because, you have to have a f coefficient pertaining to f. Okay. Coefficient. Have to have coefficient pertain to f. Okay. Now, other question you might ask is why you don't do this as an NZ plus in the mu I will call it b, and b is a number, right? Well, in this case b is 0 because two things. When you differentiate b, you will when you differentiate this, again, it's the same story with the blue highlight right here. When you differentiate it, it will become, chi times b prime. B prime is number. You found it. There's a bunch of things behind it. It will be chi. You see, chi is a function of theta. Where's f? Where's the coefficient of f? Again, that's the same thing. So therefore, we don't do a number. We don't do this form, okay? The best form is still this one. Let me highlight in red. Best form is still this one. Okay? So I encourage you to keep on asking questions, like to finally convince yourself that the red highlight is the answer. It's the good educated guess for the differential equation. And I mean, sometimes it can be a lot. It can be like a lot of work, like figuring out, but it's a process of learning until you satisfy, until you finally agree with your heart and your soul and your brain. All of that is to understand this is the most important stuff, like why we set up this form, why we want to reduce this form. Okay, I encourage you to keep on doing that. But after you agree or even disagree, next video I'm going to proceed with that thing and let's see if we can find chi, alpha, and beta. Okay, and then we can solve a differential equation ourselves. Not gonna lie, this differential equation is something very memorable for my fluid class. Like I remember emailing him and he emailed back and he named the file Justin. He named after me. I mean, he's so sweet. I mean, I don't know. I think he kind of influential, like as not a teacher but a parent as well. Like despite all his busy life, he managed to get up at 4 every day, take care of his 2 children, and take care of his wife also, and be inspirational. I try to do that. I try to do that. But yeah, Dr. Mehmet Terrace, this one for you. Like David Guetta and Zara Larson once say, this video is for you and for all of y'all audience out there. Okay, this is the first part. I'm sorry, it's kind of take long. It just, we didn't do anything. We took 50 minutes already, y'all see. But yeah, next part we're gonna continue. We're gonna go ahead and solve it. Find chi, alpha, and beta, and then we solve the differential equation.